efficient, cost-effective technology. Main features of bioremediation is that it is carried out by variety of organisms in non-sterile open environment, and microbes are highly absorbed. Goal of bioremediation is to identify suitable species which have resistant system, which are adaptable to environment, and which can give more results. Next. Now the bioremediation in situ. In situ means within that habitat. Ex situ means outside that habitat. Ex situ means we remove the soil, treat in an industry, in a factory, get it back, that will be ex situ. But in situ means where the soil is there, there is a cropland soil, water soil which is to be treated here in situ. And there are 3 levels. Natural addiction, level 1, bioremediation by indigenous microbes. Indigenous means local microbes, microorganisms. Then biostimulation means adding nutrients there. And the level 3rd is bioaugmentation, means microorganisms which are locally there. To that we can add microorganisms from other places, which we have already identified are doing good services and practically important. That can be added. So there are 3 levels. Next. Now this is a bioremediation of petroleum contaminated sites. Last point which I will tell you, in ITM University, we started work with this petroleum bioremediation in soil, and 4 indigenous bacteria were taken into consideration. Next. Now, next. Next. How we have done it? We have collected the soil and specimen from the petroleum contaminated depots, and from that, by serial dilation method, we have identified, we have grown the microbes in pH medium, National has medium, Bushman has medium, and then we have cultured 49 of these isolates of bacteria. Then out of that 4, 1, 2, 3, 4 have highest growth. That means, and you know, in that Bushman has medium, we have already added 6% petrol. That means they can live under the petroleum concentration of 6%. So they were selected. On the basis of that, 4 were selected. Further work was done. Next, then there is a zone of degradation. Again, we have identified by zone of degradation. We have taken a medium, this petroleum was added, and we have seen the zone of degradation. That gives an idea to us whether it is feasible or not, and you will see the result. Out of all these 49, these 4 were there. Next. Then, how to identify what are the microorganisms where these 4 microorganisms we have selected. We have to extract the DNA. There is a method for identification. What is the method? Extraction of DNA, then sending the then sequencing of DNA, and we get a sequence. Then there is a in US there is a we have to identify through the PLAST program, which has been developed by USA, and there is a database in the US of that where we compare it. That is through the method of bioinformatics, and we have identified these. These are only dendrograms, and these dendrograms we have got one species as Algaginelli species, and next is the Bacillus species. Next, these are known as dendrogram. Another is a Enterobacter species. Another is a Corynebacterium species. Now these, these microorganisms, what they do, they have got enzymes. They will degrade the hydrocarbons, etc. But at the same time, they also produce biosurfactants. Corynebacterium, as we see, produce biosurfactant. What is the role of biosurfactant? Biosurfactant reduces the surface tension and interfacial temperature. When the surface tension is reduced, you can recover the oil. If there is a next, so oil can be recovered. Then we have sent this to the database NCBI, and these 4 identified species are there. They have given us a number by this, and it has been recorded in the database, these 4 species. Next. Now we have done this is regarding the how to have produce biosurfactant. What are tests for that? There is a below method and there is a hemolytic activity method. And there is a screening of this next stage in this biosulfate. And then there is a how to identify the compounds. There is a FTR is to be done. Next, then there is a GCMS analysis of biosulfate. This is done, and we identify through GCMS. Next, these are the what is the biosulfate role in this hydrocarbons. You will see we have done as I told you of the 4 species. One is producing biosulfate. So we have seen what is the role of other 3 without biosulfate. And with biosulfate, as we see that biosulfate was added, there was a more degradation of the hydrocarbons in the graph. Next, then there is a formulation of consortium. Consortium, we are using single species. Actually, we have worked on 4 species, but then we can combine all the 4, or 1, 2, 3, 2, 3, 4. Also, there are various combinations. So consortium means the number of microorganisms together, and we have seen the all the 4 microorganisms that were consortium. We have set the consortium, or in that there was a maximum activity and bioremediation potential was the maximum than the single species. And there were 11 consortiums. Out of that, 1 consortium had all the next. Now, qualitative analysis, like I told you, in GCMS, what is done? That is in GCMS, we get whatever are the compounds. Suppose there are 40 compounds, all the 40 compounds will be listed in a petroleum. So we have taken a normal petroleum, and then petroleum treated with microorganisms, and then liquid for 7 days, and then the liquid was is solidified, and then we have seen. Then we have done this GCMS, and we have compared what is the effect on each compound. One is total hydrocarbon, total petroleum, and another is within the total how much is effect of each biosulfate that through the GCMS, and you see, as I see, that there is a total degradation was 11.65 and 8.11% and 5.59%. But by this, by Taylor considered 0, there was an 80% degradation. Next, these are the chromatograms of GCMS. Next, again. Now there is another hierarchy by next. Now there is another study that is regarding the heavy metals, and this is how the bioremediation processes. Mediums, bacteria, how they absorb, they bioaccumulate, they will detoxify, they will biotransformation. At the top you will see toxic metals are there, but at the end you will see either they are bioaccumulated by microbes, or they are detoxified, or they are transformed so that they are less toxic. Next. Then again we have taken here, bacteria is a different study. One of them is a Bacillus cereus. Identification, this is the diagram. As in the previous work, we have taken soil from this Johnson, which generates electricity plants. From the waste of that, we have taken, which contain a very high quantity of the heavy metals. From that, we have identified by the same process. First, we serial dilution, then identified 4 species, then identified them. Then do the further work. So this is the dendrogram of Bacillus cereus. Next. This is the Pseudomonas argina next species. Next is Lysic Bacillus fusiformis, Serratia marcins. Serratia marcins also produced biosulfate. Next. Then you just see the we have added mercury 200 milligrams, 400 milligrams, 550, and this is a minimum in laboratory concentration, and we have taken various concentrations. How much is the minimum in laboratory concentration by them? And this is the mercury, you will see, is very toxic, so minimum in laboratory concentration in Pseudomonas is 135, Bacillus cereus is 200, and least is in zinc. You know, zinc is a good nutrient, but higher quantities is toxic, but its minimum concentration is high value, that means it's less toxic. Lead is also like next. This is again the removal of the lead in 72 hours, Now, let us say best lecturers, 100 to 500. Then is 100, 200, 300, 400, 500 by treatments, and the result was removal was 94.1. Then less until it last was 38. So like that we have done the work. You can see they are removing the lead. Next is again mercury. Again. Okay, next. Now there is another phytoremediation. Is that next or next? This is a phytoremediation means this is the third study. That means removal by the plants. Plants can be used. Now you know the plants uptake our nutrients, but they take heavy metals also. So they should be tolerant. Many plants die, and if they are tolerant, they will uptake. But then again, the problem is this: there are many plants which uptake more than others. There are 225,000 angiosperms in the world. Out of that, 400 species, only 400 have been identified, which take fast, especially heavy metals. They are known as bioaccumulators. So these are 6 processes of phytoremediation while involving phytoextraction, phytosublimation, lysophiltration. This. Now next. But kindly conclude. Next. Now as I told you, 400 species have been identified about all this. And in these, the 2 important things are translocation factor and concentration factor. Translocation factor means how much from the root will you shoot, or the metal will go. That's a good sign. If it is a higher level, it goes to shoot, then we can harvest the plant, and shoot we can remove to other place. So the translocation factor is important. And biotranslocation factor is from the soil, how much it goes to the that's a biosubstituted. These are important factors. We studied 3 plants, Sesbania bispinosa, Sorghum vulgare, and Chinamonium. And conclusion drawn was that Sesbania bispinosa is a hyperaccumulator for lead and the point which I want to emphasize, the 400 species which are being identified as a hyperaccumulator are from all over the world. In India, we are the first people who have identified a hyperaccumulator species. And hyperaccumulator species is we have identified is a dancha. Hindi name is dancha. That is a sir, kindly conclude. Sesbania bispinosa, and this is the and this dancha is normally used since thousands of years as a fallow land. What's a fallow land? Fallow land means every year we grow the crops. Then we leave that land vacant. That is what a fallow land. So from ancient civilization, we found that this plant is being used as a fallow land. Then I thought that it must have some quality. It must be removing some heavy metals or anything. Although it's a lignous plant, nitrification takes place, nitrogen fixation takes place. But then our concept really got when we actually did the work on this. Thank you very much. Thank you very much.
Shilpi Lavania, thank you very much, sir. All the speakers are advised to stick to their timings because we have many presenters. So if we exceed the times, we are going to eat others' time.
A very good morning, everyone. I'm Dr. Shilpi Lavania from Department of Electronics and Communication Engineering, Dr. Bhimrao Ambedkar University, Agra. First of all, I would like to congratulate the entire team on the successful organization of this conference. And second, I would like to thank Chairman sir, Director sir, and Principal sir for giving me an opportunity to contribute a little with this small lecture in this international conference. I will keep my talk very short, and I have divided my presentation in 2 parts. One is related to the research content, and the other one especially for the students, because ultimately we are here only for the students.